Hi there! In this video we're going to be talking about common errors that people make with loops. There's two different loops that we've discussed, while loops and for loops. And you can always use either loop to accomplish your task. So why would somebody pick a for loop over a while loop or vice versa? It has to do with what we use them for. Primarily we use while loops when we're doing menu-driven programs, and when we're reading in information and we're not sure how many times we're going to read stuff in. While loops are good when we don't know the concrete number of times because we can just go until some condition is met. For loops are commonly used when we do know how many iterations we need to perform. It's great for accumulation, for calculating sums, for printing charts, and for reading in lists when we know how many things we're going to be reading in. Let's look at some common errors. Most errors with loops manifest in the same way. They almost always look like infinite loops. If you haven't seen an infinite loop in your practice problems yet, let's go ahead and start with a demonstration. This is our first problem program. It's called Error 4. And if you haven't yet, you might want to pause the video and download the error program so that you can follow along. This is the segment from the slide that has a problem, and we're going to see what that problem looks like. So we build and run our program. It's printing out this statement, Florida is hot, over and over and over again infinitely, even though we've intended it to print 10 times. So technically it's still going. You can see if I hold it here for a second, if I pause it, it's still going. It's not going to quit, and there's no way to stop it except to close the runtime window. So let's trace through our code and figure out what the problem is. In main, we have this integer counter, which we've started at 0. And as long as count is less than 10, we're going to print our statement. There's nothing in the while loop that changes the value of count. Count is 0, 0 is less than 10, print the statement, check the conditional expression, count is 0, 0 is less than 10, print the statement, check the conditional expression. Nothing changes to make it so that count is not eventually equal to or greater than 10. So an easy fix is just to add an increment for count. This should print our statement now 10 times. If we build and run, we see 10 statements of Florida is hot rather than an infinitely running program. And of course, we can change the number of times that this prints out just by modifying this increment statement. Here's a reminder of the shorthand that we talked about in our previous video. This is the same as saying count should be equal to count plus 2. So we'll add 2 to count each time, which means we're only going to see 5 statements, because count will have the value 0, 2, 4, 6, and 8. Let's move on to the next error problem. In this program, we've built a while loop to run until the user enters an even number. And every time they give us a number, we're going to print out whether it is or is not even. So they can keep giving us values, and as long as they're odd, we'll keep asking for new values. But when it's even, we're supposed to stop. So let's take a look. If we build and run, we haven't prompted the user with any information, so it's just going to sit here and wait for input. So as long as it's not an even number, it's supposed to keep going. It should stop when we give it an even number, but it doesn't. So our program has again given us an infinite loop. Even though this one waits each time for input, it's not quitting like it should when we give it an even number. So we're going to have to close it here and try and figure out why our program's not working the way we think it should. We have 2 values that we've declared, num, that's the value from the user, and flag. And remember, flag is a common concept where we set it to some initial value, and then we change it when we need to turn something off, like a light switch. This one says, while flag equal to 1. But let's read this very carefully and make sure we're reading what it says and not just what we think it should say. It says, while flag 1 equal sign 1. This is very important. It's a very common error. 1 equal sign is an assignment statement. This sets flag equal to 1. 2 equal signs is a relational operator, which is what we need to use in our conditional expressions. So 1 is an assignment statement. It is setting flag to 1 and running the loop. When instead we want to check to see if flag is equal to 1. And we can see in here flag changes to 0 when we encounter an even number. That's what's intended to break our loop. So if we put in that change, if we make this a relational operator instead of an assignment statement, odd numbers respond the same way, and even numbers allow us to break out of the loop. Let's look at the next error problem. This loop is intended to print out random numbers until we encounter one that is not less than 100. So we've declared num1 equal to 100, and as long as our random numbers are less than that, we're going to keep printing random numbers. So let's take a look and see what that looks like. So for the third time, we have an error that manifests itself as an infinite loop. This is a type of logical error. It's always making random numbers and printing them out and making new ones and printing them out, and it's not going to stop. So let's take a look at why. We've declared this value to be 100. We've seeded our pseudo-random number generator. Say as long as num2 is less than num1, keep making these values. So here's where num2 updates. Num2 will have to eventually be equal to or greater than num1 in order for us to break out of the loop. But we're modding by 100. So remember, when we mod, we're going to get the remainder as if we had divided by 100. Now all the possible remainders from dividing by 100 are 0 to 99, all of which are less than 100. So this is called an unreachable condition. We've expressed this conditional expression, but it's no way for it to become false given the setup that we have. So we'll have to fix that. We have to make it so this can eventually become false. And there's several different ways we can do that. The easiest fix is just to modify our range so that there are some possible values that are greater than 100. And this way, even if it takes a while, the loop will eventually end. Now let's look at our error program, error 7. This is intended to calculate the sum of all the values from 1 to 10 using a for loop. So we're going to go ahead and build and run our program and see what it says. It says the sum of values from 1 to 10 is 11, which we know isn't quite right. It's not high enough. So there's something going wrong in our program, and we have to figure out what it is. So we'll check our values. We have two integers. Sum starts at 0. I is not initialized until the beginning of our for loop. Our for loop says I is equal to 1. As long as I is less than or equal to 10. Here's the problem. This is similar to one that we saw in if statements. This introduces an empty statement into our construct. And just like if statements, for loops and while loops can only hold one statement inside them unless we employ those curly brackets. So what this is actually saying syntactically is that as long as I is less than or equal to 10, do nothing. It sets I equal to 1, checks to see if it's less than or equal to 10. If it is, do nothing, increment I. Check to see if I is less than or equal to 10. If it is, do nothing. I will eventually become 11, which is the first value that's not less than or equal to 10. And that is when we add I to sum, which is why we see as our current output, the sum is 11. So of course this is an easy problem to fix. We just need to get rid of that empty statement. And the next time we run our program, we should see the correct output, which is that the sum of all the values from 1 to 10 is 55. So we're going to see the same issue except with a while loop. Here's the while loop version. We have our sum and our I. We have to do our initialization before the loop starts. And as long as I is less than 10, increment I and add that value to sum. You can see when we first run it, we have the same logical error as before. The program runs, it doesn't crash it, but the output it produces is incorrect, so logical error. It says the sum of 1 to 10 is 10, which we now know isn't right. And the problem we're having is that the only thing that's actually inside the while loop is this increment statement. So C is not concerned about our indentation. What it sees is something more like this. This is the contents of the while loop, and it doesn't matter where we put this accumulation statement, it doesn't see it as part of the loop until we encapsulate it with these brackets. So now when both statements are part of the loop, if we run the program again, we should see the correct output, which is that the sum of 1 to 10 is 55. So that's a look at some of the more common errors that people make with loops. It's important to be able to read your code to try and find out what precisely is going wrong when you encounter a logical error. Your ability to read code is almost as important as your ability to write code. In our next chapter, we'll start looking at how C can interact with files, with file input and output. I will see you there.